Oh, hi there. I'm sure you're very excited to learn about how you can save time in grade 12 advanced functions by expanding binomials using, well, many people have laid claim to this triangle, this special triangle of adding numbers together in a triangle. All right. So when we're using Pascal's triangle, we can look at something like a plus b to the n. And we can recognize that if we use the nth row of this triangle, we get the coefficients for that expansion. If you look at something like a plus b to the 0, that's so trivially easy, we just know that to be 1. You can think of that as the top row, this part of your Pascal's triangle. This is row 0. This is row 1 here. And row 1, a plus b to the 1, well, that's just a plus b. That's just that thing. And its coefficients are 1 and 1. This number and that number, 1a and 1b. If we look at a plus b squared, something we've been working on since grade 10, I don't think many of you did this in grade 9. We know that to be a squared plus 2ab plus b squared. Quick review. A plus b multiplied by a plus b, we FOIL. There's your a squared. There's your plus ab. There's another ab. And there's your b squared. So you end up with 2ab in the middle. And there it is. And the coefficients, 1a squared plus 2ab plus 1b squared. Look at that. There they are right there. Pretty cool. Now, wouldn't you know that all of them going down will do that. A plus b to the 3 is right here. A cubed plus 3a squared b plus 3ab squared plus b cubed. We did that one by hand. It was already a little bit like, oh, that was some doing. But there it is right there in your triangle. Like a lot of you filled in this triangle completely and made no mistakes. You can already do this to the 11th level. That's the 11th level. And you could carry it on if you had a bit more time. So if you had to expand something like a plus b to the 11, you could just build that triangle again or Google it and find the coefficients right there on the 11th level. All right. So another thing that we can notice about the exponents for these terms is the first one here, a. It starts with the exponent that equals the layer that you're on. So if I'm on the second layer here, then I start with a squared. If I'm on the third layer, I start with a cubed. And then that exponent just goes down by 1 until it gets to a to the 0 over here. This is like a to the 0 plus b to the 0. Oh, wait, no, it isn't. It's not a to the 0 plus b to the 0. It's just the whole thing to the 0 is 1. Okay, so don't worry about that. Okay, so if we wanted to do something like g plus m to the 8, what's that going to look like? Let's go ahead and find it. Find your 8th row. So here it is here. Notice that these rows are conveniently numbered by the second number in there. You can always see the row number because you just have ascending integers down that diagonal stripe of the triangle. So 1, 8, 28, 56, 70. 1, 8, 28, 56, 70. You can copy those out. 1, 8, 28, 56, 70. And then they keep going. I need to write smaller. Just going to zoom in. Huh? No, I didn't forget 1. We don't usually write ones. 1, 8, 28, 56, 70, 56, 28, 8. And then we can go ahead and put in our G's and M's. This will be 1G to the 8 plus 8G to the 7 M. 28G to the 6 m squared. 56 g to the 5 m to the 3. 70 g to the 4 m to the 4. Oh, and sorry, these are all plus, 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 plus. 56 g to the 3 m to the 5 plus 28 g to the 2 m to the 6 plus 8g m to the 7 plus m to the 8.
Mr. Jennings,
Yeah.
I'm confused what this is or what the point 2 is.
So you can expand those without having to do them by hand.
Where did you get the
Huh?
8? Where did you get the
8?
8?
Oh, I got it from this row of the triangle.
Okay.
Right there. See? 1, 8, 28, 56, 70, 56, 28, 8, 1. So you just go down to that row of the triangle. Those are your coefficients for expanding these binomials. And then you go ahead and expand them. We can write that out nicer. G to the 8 plus 8 g to the 7 m plus 28 g to the 6 m squared plus 56 g to the 5 m to the 3 plus 70 g to the 4 m to the 4 plus 56 g to the 3 m to the 5 plus 28 g squared m to the 6 plus 8 g m to the 7 plus m to the 8. So you can see the pattern in the exponents. This is m to the 0. It's not there, so we don't usually write that. M to the 1, we don't usually write this 1. It's not there. M to the 2, M to the 3, M to the 4, M to the 5, M to the 6, M to the 7, M to the 8. And then the exponents of g are likewise descending as you go across. And your coefficients are right there. So that's how you can expand these with a shortcut using Pascal's triangle next year. And if you have something like this, where you don't have a simple a and b in there or something with some numbers in there already, you can still use this trick. Let's work it out. First, we want to locate the fourth row of Pascal's triangle, or Khayyam's triangle, or Yanghui's triangle, or whichever one of the historical mathematicians that you're interested in, which has looked at this triangle. There it is there. 1, 4, 6, 4, 1. That one's pretty easy to remember. So let's do that. And go ahead and get into that bit of paper there. Move your face if your face happens to be in the way. And then let's get a fresh pen. We'll do this in red. We'll do this in black. All right. So I remember these numbers as 1, 4, 6, 4, 1. I don't intend to write down the ones. Okay. And then I'm going to have this one over here. This time I'm going to put these in brackets. 3a, put it in brackets, to the 4, minus 5b to the 0. Okay. And then we're going to have plus 4 times 3a to the 3 multiplied by negative 5b plus 6 times 3a squared times negative 5b squared plus 4 times 3a times negative 5b cubed plus negative 5b to the 4. Now we have some simplification to do. So let's go. 3a to the 4. Well, that's 81a to the 4. I have to raise 3 to the power 4 as well. Plus 4 times 3 cubed times negative 5. 3 cubed is 27. 4 times 27 is 108. 108 times negative 5 is 540, but it's negative. So instead of plus, we could have minus 540 a cubed b. Oh, sure. So let's have more lines, shall we? You just work it out. So let's do plus 4 times 3 cubed is 27. Negative 5 is negative 5. And then we're going to have an a cubed b. Okay? And then we know that's going to work out to negative 540. Plus, this time I'm going to have a positive term here because negative 5 squared is going to be positive 25. So I'm going to have plus 6 times 3 squared is 9 times negative 5 squared is 25. A squared b squared plus 4 times 3 times negative 5 cubed. Negative 5 cubed is negative 125. And that's going to be an a b cubed. And then this is going to be plus as well because negative 5 to the 4, there's 4 negatives, so that's going to be a positive. Negative 5 times negative 5 times negative 5 times negative 5 is positive 625. Equals 81 a to the 4 plus 4 times 27 is 108. 108 times negative 5 is, again, I wrote plus, bad habit, minus 540 a cubed b plus 6 times 9. 6 times 9 is 54. Let's do it the other way. 6 times 25 is 150. 150 times 9 is 1350. 1350. Yeah. And your calculator would tell you the same thing. A squared b squared. 4 times 3 is 12. We can do it the other way. 4 times 125 is negative 500. Negative 500 times 3 is negative 1500. So that's how you can do that with a shortcut.
What would you use this for?
Exactly this. Expanding these types of expressions.
I mean, like, what would you use that?
Like when would you use it in the grocery store? You wouldn't use it in the grocery store. Some math, Malcolm, you use for math so that you can do better math, so that you can change the world with things like computers. I know Malcolm was thinking the same thing. If I'm not going to use it in the grocery store, why do I need it?
Like, I mean, I don't think a computer algorithm is going to produce that.
You could type this into a computer and it'd make that number.
Yeah.
Okay, but
That's the computer algorithm producing that.
you know, what is it? Can we,
So
That little program that runs in your mind of when am I ever going to need this is consuming computing power that you don't need to devote to that. I mean, you can devote it to that, but you don't need to. It's up to you. Okay, and in order to practice this skill and to get ready for later on, practice these questions here, as well as what else to say? Yeah, practice material from the last couple days, or ask me questions from the textbook that you have. We have a good amount of time, a half hour to practice, so go for it. If you want, I feel like we could look at another example like this. I'll do one on the sideboard. I'll just make one up. Yeah.